Astronomers discover planet with rare jewels. Rainy days are often quite unpleasant, but on this planet, where they have the potential to make you affluent, that is not the case. On this remarkably familiar planet, billions of years of impacts have transformed most of the graphite crust into spectacular jewels. Dazzling diamonds may have been created by a confluence of violent meteorite strikes, and pieces of the planets form a graphite shell. Do you want to know which planet we're alluding to? The answer is startling. It's none other than Mercury, the smallest and the closest planet to the Sun in our solar system. Deep craters adorn the surface of Mercury, similar to what the Moon does on Earth. In its early years, Mercury encountered a violent period which resulted in something totally unfathomable and shocking. But before we continue, be sure to subscribe to our channel, Future Collective, for more amazing videos just like this one. With that out of the way, let's get to it. Mercury experienced a catastrophic explosion in the ancient past characterized as the Late Heavy Bombardment, which occurred 4 billion years ago when the solar system as a whole witnessed a dramatic increase in asteroid hits. Mercury's surface is now completely covered by a huge crater, which is indicative of an impact-filled history. Because of this, the surface of Mercury's craters could contain valuable diamond crystals. The sparkling planet could have evolved as a result of the crust of Mercury being flash-baked by meteorite strikes over billions of years. Kevin Cannon, a planetary scientist from the Colorado School of Mines, presented the new findings at the Lunar and Planetary Science Conference. Cannon focused his attention on the planet closest to the Sun when examining impact-borne diamonds. Surveys of the planet's surface and assessments of molten rock have led scientists to speculate that the planet's crust may still include remnants of an ancient shell composed of the carbon material graphite. Abrasive impacts can turn carbon into diamond by creating extremely high pressures and temperatures. A large portion of the hypothesized graphite crust would have been damaged and turned into diamond. The most plausible explanation for this is that, akin to other planets in the solar system, when Mercury initially formed, it was partially obscured by lava that eventually cooled and solidified. A layer of graphite drifted toward the top of all the molten rocks as Mercury's surface began to cool. Much of Mercury's surface may have been flash-baked into the sparkling diamonds over the course of billions of years by meteoric strikes. As a result, scientists began looking to Mercury for the study of the prospect of impact-borne diamonds after discovering that graphite, a mineral rich in carbon, may be present on the planet's surface in prior scans of the planet and molten rock. On Earth, the upper mantle, about 100 miles below the surface, is where diamonds are formed. Carbon atoms link together at high temperatures and pressures. When there are volcanic explosions, the gemstones then ascend to the surface. However, research on the meteorites indicates that asteroid impacts can produce substantial, brilliant diamonds. Cannon employed computers to replicate 4.5 billion years' worth of strikes on a graphite crust in order to determine just how ubiquitous this diamond forging may have been. According to the research, Mercury would have accumulated 16 quadrillion tons of diamonds, or nearly 16 times the estimated reserves on Earth. If it had a skin of graphite 300 meters thick, later strikes would have likely damaged some of the diamonds, due to the fact that diamonds have a melting point that is more than 4,000 degrees Celsius. The losses would have been quite negligible. Remelting from collisions would be included in the next simulations, which could enhance our comprehension of how much diamond is now viable on Mercury. The investigation team is performing additional calculations to look at how meteorite impact melts diamonds. When the Bepi Colombo mission arrives on Mercury in 2025, there might be a likelihood of scouting for diamonds there. With that, our video has come to an end here. Don't forget to subscribe to our channel, Future Collective, and hit that bell icon for more future-related content. Thanks for watching, and I'll see you in the next video.